Hello, you all are most welcome to eTuition. In this small session of today, I'm going to discuss about the very basics of trigonometry. For those who are just a beginner to this portion of mathematics, this video is going to be very helpful and useful. Alright, so first you need to know what trigonometry is. As you see, okay, I've kept here written for you that ancient Greek trigonon means a triangle, and the next word is metron means measure or measurement, right? So what trigonometry means is a measurement of something of triangle. What is that something? You need to know that something is basically the relationship between the sides of a triangle with the angles of the triangle, right? So trigonometry is a branch of mathematics that studies the relationships between the side lengths and the angles of triangles, right? So that's what trigonometry is all about. It is very important part of mathematics. This basically emerged in the Hellenistic world during the 3rd century BC from applications of geometry to astronomical studies, right? So this is quite old, you can easily understand. This is quite important also for those students who are aspiring to proceed in the science stream in the higher studies. For them, basically, this trigonometry is very important. For example, if you want to study in science stream from class 11 onwards, higher trigonometry will come in front of you. Angles, chapters like allied angles, compound angles, multiple angles, submultiple angles, okay, and properties of triangles, and these things are going to come one by one in front of you. So this is quite important for those students who will be studying in science stream as well as those who will study engineering, right? So this thing is very important. If you're a beginner of class 8 or 9, then you may have to study these things and understand these things for the first time. So for them, this video is going to be very helpful. I thought of making a small video with the very basics, very fundamentals of trigonometry. For the time being, we have to study the relationship between angles and sides of a triangle which is right angled, but afterwards you'll gradually have relationship for any kind of triangle. Okay, the relationship between side lengths and angles for any kind of triangle, right? So without wasting any much time, so let us make a beginning. Yes, my name is Bapindas and you are watching eTuition. So the very basic things that we need to know out here is that the relationship between the side lengths and angles of a triangle which is right angle. What is a right angle triangle? A triangle whose one angle is right angle, right? Is called a right angle triangle, and in fact more than one right angle is impossible for a triangle, because we know the sum of all the three angles is 180-degree, right? If one angle is right angle, then sum of the other two angles is definitely another right angle, right? So that is, we can say that the other two angles are acute angles. All right, so with respect to any of these two acute angles, we can specify or define the ratios, which we shall study here. See, have a look at what I've kept written for you to see. Trigonometrical ratios of acute angles. This angle is actually the acute angle, right? Acute angle is what is an acute angle? What is an acute angle? An angle which lies between the magnitudes 0 degree and 90 degree is what we call an acute angle. So keep it in mind that the acute angle with respect to which we are defining the ratios is the angle between the hypotenuse and the base of the right angle triangle. All right, I'm repeating, the acute angle with respect to which we are defining these ratios is the one which lies between the hypotenuse and the base of the right angle triangle. Keep it in mind. So here you can see, for this right angle triangle, this is actually the base. Capital B is the one with which I denote it. This is the perpendicular or the height, also it is said to be sometimes, right? Perpendicular here, okay, I've denoted with capital P, and this is the hypotenuse which is denoted by capital H, right? Symbols for perpendicular, base and hypotenuse are P, B and H. Keep it in mind. All right, this angle is 90 degree, as we know, or the side of the right angle triangle which is just opposite to the right angle is the hypotenuse, right? because hypotenuse is literally the longest side of a right angle triangle, and it is the one opposite to the right angle. So this is the hypotenuse, which is denoted by capital H. This is perpendicular, capital P. This is the base, capital B, right? This is 90 degree the right angle. This is the acute angle, that is the angle between the base and the hypotenuse. Okay, that is denoted by an alphabet in Greek letters, that is theta. A Greek alphabet is theta. Okay, so this is theta actually. This is, is theta. THEETA. This is theta as it is said. Okay, a letter of Greek alphabets. So now let's come to the ratios. Ratios are, first one is sine theta. Sine theta. This is not sin theta. This is read as sine theta. The full form of it is SINE. We don't write the full forms. Okay, so we make use of the short forms. Short forms is are sine theta, cos theta, and third one is tan theta, right? First one is sine theta. Sine theta is equal to perpendicular upon hypotenuse, right? Second one is cos theta. The full form of cos theta is cosine. Full form of cos is cosine, right? But we make use of the short forms in writing, in speaking. Okay, always, everywhere. Sin theta equal to perpendicular upon hypotenuse, and cos theta equal to base upon hypotenuse. Okay, third one is tan theta is equal to perpendicular upon base. All right, the reciprocals of these three basic ratios, okay, are defined also. Reciprocal of sin theta is cosec theta equal to h upon p, that is hypotenuse upon perpendicular. Okay, and that for cos theta equal to hypotenuse upon base, and the reciprocal, okay, of tan theta is cot theta equal to base upon perpendicular. Okay, just the reciprocal, keep it in mind. A point to be noted here is that sin theta is never equal to sine into theta. All right, sine theta is never equal to sine into theta, right? Never ever think like that. Sine and theta are not two different things. They are parts and parcels of the same single thing. Sine theta means sine theta literally means the ratio of perpendicular to hypotenuse of a triangle whose one acute angle is theta. I'm repeating, the ratio of the perpendicular to hypotenuse of a right angle triangle whose angle between the base and the hypotenuse is theta. Yes, भाई साहब. Okay, अब देखिए, theta is the acute angle between the base and hypotenuse. The acute angle with respect to which we define these trigonometrical ratios is the angle which lies between the base and the hypotenuse. I told you before, few minutes ago only, right? This is the acute angle. Okay, so which is theta, the one between the base and the hypotenuse. Because with respect to this acute angle, we can call this side as base and this one as perpendicular, right? Otherwise, if you change the acute angle from this angle to this upper one, then the base and the hypotenuse just interchange, isn't it? Then this one becomes the base and this one becomes the perpendicular, and this acute angle is 90 degree minus theta, right? That is what I want to make you understand. Keep it for certain that the angle with respect to which we define these ratios is the one which lies between the base and the hypotenuse. Okay, all I am trying is to make you understand in this with the simplest of words and with the best of my efforts, right? So keep your ears open and keep your brain sharp. Sin theta equal to perpendicular by hypotenuse, cosec theta equal to hypotenuse by perpendicular, cos theta equal to base by hypotenuse, sec theta equal to hypotenuse by base, tan theta equal to perpendicular by base, and cot theta equal to base by perpendicular. All right. So here I have also written the reciprocal relationships. Cosec theta is equal to 1 by sin theta, and vice versa. You may also say sin theta is equal to 1 by cosec theta, right? In that way. And here sec theta equal to 1 by cos theta, cot theta equal to 1 by what? That is tan theta, right? Also we can write, see, also we can write sin theta multiplied by cosec theta equal to 1, definitely, because they are reciprocal of each other. Sin theta multiplied by cosec theta equal to 1. Oh, all right. And cos theta multiplied by sec theta is equal to 1, and tan theta multiplied by cot theta also equal to 1. All right. Again, one more thing to take care of, one more thing to be noted is that, see, tan theta is equal to sin theta upon cos theta. How is that coming? All right, I'm showing you, just see. See, I'm showing you how this thing is coming. Tan theta, what is tan theta? What is tan theta? Tan theta is equal to perpendicular by hypotenuse by base, right? So am I able to write it in this way? Perpendicular by hypotenuse whole divided by base by hypotenuse. Of course I can, because this hypotenuse and hypotenuse, h and h are cancelling each other from upper and lower side, right? So this literally is becoming equal to perpendicular by base. Now say what the thing in numerator is. Perpendicular upon hypotenuse is what sine theta is, right? So in numerator, can I write sine theta? Of course I can, isn't it? And denominator, base upon hypotenuse is what cos theta is, right? So in denominator I can write cos theta. That is why we can write this tan theta is equal to sine theta by cos theta, right? And similarly for this one, that is cot theta equal to cos theta upon sine theta, right? You can give it a try on your own in order to see, okay, if this thing is actually becoming or not, right? So after this much for the basics, sine theta equal to p by h, cos theta equal to b by h, tan theta equal to p by b, right? And the reciprocals are defined. Reciprocal of sine is cosec, reciprocal of cos is sec, reciprocal of tan is cot, right? Listen, once again I'm telling, sine theta is not equal to sine into theta. Without theta sine is meaningless, without theta cos is meaningless, without theta next thing is tan is meaningless as well. So they are combined together, they're combined together. That doesn't mean sine theta equal to sine into theta, of course. Okay, sine theta, it means ratio of perpendicular to hypotenuse of a triangle whose angle between base and hypotenuse is theta. Cos theta, it denotes the ratio between the base and hypotenuse of a triangle whose angle between the base and hypotenuse is theta. Acute angle, of course, okay, it has to lie between 0 degree and 90 degree, keep it in mind. All right. So after that, one more important thing I want to let you know, that is Pythagoras theorem. That is Pythagoras theorem. What is Pythagoras theorem? Have a look at this. Pythagoras theorem is one more important thing which we shall require to prove some basic trigonometric formulas, or identities you may also say. Pythagoras theorem, what does it say? The area of the square drawn on the hypotenuse of a right angled triangle is equal to the sum of areas of the squares drawn on the other two sides. As simple as that. This is a triangle which is a right angle. You can see this angle is 90 degree, so this side is becoming hypotenuse, right? This side is becoming the hypotenuse, this side is becoming the base, and this is becoming the perpendicular. So see, the square drawn on the hypotenuse, this is a square which is drawn on the hypotenuse. What's going to be the area of the square? What's the formula for the area of a square? The formula for the area of a square is side square, right? This is a square's four sides equal, and each side is equal to the hypotenuse of this right angled triangle. So necessarily the area of this square is hypotenuse square, that is h square, right? Similarly, other two squares are drawn on the other two sides of this right angled triangle, and the areas of these squares are also p square and b square, perpendicular square and base square, right? So now have a look once again at the statement of this Pythagoras theorem. Area of the square drawn on the hypotenuse of a right angled triangle, okay, that is the area of this bigger square which is drawn on the hypotenuse, is equal to the sum of areas of the squares drawn on the other two sides. can easily understand that the area of this bigger square is equal to the area of these two smaller squares which are drawn on the other two sides of the right angle triangle, isn't it? Isn't it easy to understand? Yes, it's pretty simple to understand. So that is, we can write hypotenuse squared is equal to perpendicular squared plus base squared, right? Or h square equal to p square plus b square. So from this we can write h square minus p square equal to what? B square. Again, h square minus b square is equal to p square, right? These two relations we can write from the main statement, mathematical statement of Pythagoras theorem by simply a side change. P square is taken to the left side in order to give you h square minus p square equal to b square. Again if b square is taken to the left, okay, so that will fetch you h square minus b square equal to p square, right? Keep these things in mind, I'm telling you, because these three relations are going to come to your use in order to prove the basic trigonometric identities which just now I'm going to show you, right? So that's all what Pythagoras theorem is all about. Yes, now I've come to the proof of the first trigonometric identity. What is that? Sine square theta plus cos square theta equal to 1. Yes, that's a very basic trigonometric identity which will come to use in solving many trigonometric identities and sums and problems, right? So let us have a look at what this thing says. Sine square theta. Okay, what is sine square theta? I'm starting from the LHS, that is left hand side, right? Sine square theta plus cos square theta. What was sine square theta? Just remember, I told you a few minutes ago. What was sine square theta? What was sine theta? Tell me that. What was sine theta? Sine theta equal to p by h, perpendicular by hypotenuse, right? So that's what I'm writing here. P by h होल स्क्वायर, राइट? साइन स्क्वायर थीटा है ना यहाँ पे, इसीलिए p बाई एच होल स्क्वायर ही लिख रहा हूँ. उसके बाद cos थीटा. व्हाट वाज cos थीटा? b बाई h बेस बाई हाइपोटेन्यूज, राइट? सो आई एम राइटिंग b बाई h का होल स्क्वायर, ठीक है? सो आफ्टर दैट p बाई h होल स्क्वायर का मतलब p स्क्वायर बाई h स्क्वायर, b बाई h होल स्क्वायर का मतलब b स्क्वायर अपॉन h स्क्वायर, राइट? तो इसके बाद सिंपल एडिशन कीजिए. h square comes in the LCM and in numerator is remaining p square plus b square, right? What is p square plus b square? As per Pythagoras theorem, what was this? h square. भाई साहब बताइए, h square. See, I'm showing you again. p square plus b square is equal to h square. Am I right? That's what Pythagoras theorem says. Yes, that is true. p square plus b square के जगह पे हम लिख सकते हैं h square, isn't it? h square by h square. h square से h square तो मर गया, तो क्या रहा? 1 रहा, ठीक है? LH is equal to RHS. yes, हम साबित कर चुका. LH is equal to RHS, that is sin square theta plus cos square theta equal to 1. Okay. From this relation we can write by doing a side change. Sin square theta is equal to 1 minus cos square theta. Yes, this thing is also going to come to your use. Okay, keep it noted. Sin square theta equal to 1 minus cos theta, or you may also write cos square theta equal to 1 minus sin square theta, right? Yes, as simple as that. So from this we can also write sin theta is equal to under root 1 minus cos square theta, right? And from here, in a very similar way, you can write by taking a square root of both sides. Cos theta is equal to root over 1 minus sin square theta, right? So these 5 relations in total okay, are actually the same thing. Keep it in mind. Main thing is what I've kept within box. Sine square theta plus cos square theta is equal to 1. From these you're getting sine square theta is equal to 1 minus cos square theta, or cos square theta equal to 1 minus sine square theta, right? And these are just sine theta and cos theta, taking square root of both sides of these two relations. Okay, now that's what I've written here in this portion. All right, so now the first identity is done. You got to learn a very new thing: sine square theta plus cos square theta equal. Very basic and fundamental things are the three basic relations, three basic trigonometrical ratios of acute angles: sine theta, cos theta, and third one is tan theta. Sine theta equal to p by h, cos theta equal to b by h, and tan theta equal to p by b. ध्यान रखना, याद रखो, ठीक है. Sin theta equal to p by h perpendicular by hypotenuse, cos theta equal to b by h यानी कि base by hypotenuse, and tan theta equal to p by b अर्थात perpendicular by base, right? Keep it in mind. So by making, and the reciprocals are cosec theta, sec theta, and the reciprocal of tan theta is cot theta. Sin, cos, tan, the reciprocals are cosec, sec, and cot. All right, keep it in mind. Now I'm moving on to the next identity, right? Next identity, that is the second one, is sec square theta minus tan square theta is equal to 1. So let us approach to prove in a very similar way. I'm starting with the LHS, the left hand side. Sec square theta minus tan square theta, right? What was sec theta? Sec theta was the reciprocal of cos theta, right? Cos theta was base by hypotenuse, b by h. So sec theta is hypotenuse by base, h by b, isn't it? Have a look once again. h by b, right? And इसका square भी कर दो. Minus what was tan theta? Minus what was tan theta? Tan theta was perpendicular by base. Am I right? I hope I'm right. Of course I am. p by b whole square, right? से बहुत सिंपल सा सब्ट्रैक्शन ही कर लो. a square minus b square minus p square minus b square. So b square is coming in denominator as a LCM. In numerator is remaining h square minus p square. Now tell me what this h square minus p square is equal to. As per Pythagoras theorem, this is equal to b square. हाँ जी, देख लीजिए और एक बार दिखाते हैं Pythagoras theorem. See, h square minus p square is equal to b square. Yes, h square minus p square is बराबर to b square. So h square minus p square के जगह पे हम बिल्कुल लिख सकते हैं b square, right? b square minus divided by b square. b square को मार डाला, क्या रहा? 1 रहा, is equal to RHS, right? So yes, the second identity as well is successfully proved. That is sec square theta minus tan square theta is equal to, this is pretty important, that comes to use so frequently. Keep it in all these three identities. Okay, so which I'm telling you now are very important. The first one I've shown you already, that is sin square theta plus cos square theta equal to 1. Second one is this one, sec square theta minus tan square theta equal to 1. Third one is going to come. Have patience for 2 more minutes. See, sec square theta is equal to 1 plus tan square theta. Yes, we can write this by making a simple side change, isn't it? So from here you can again write sec theta equal to root over 1 plus tan square theta, right? Okay, and another thing which you can write by doing another side change which is different from the previous one, that is that is when you take this tan square theta to the right side and take this plus 1 to the left side, what does it give you? That gives you sec square theta minus 1 is equal to tan square theta, right? Isn't it? Of course it is. So from here you can again write tan theta is equal to root over sec square theta minus 1. Tan that tan theta is equal to root over sec square theta minus 1. All right, so these 5 things again I'm telling are literally the same thing, that is the second identity, different forms of the second identity. The main thing which I've kept within box is the one which you need to keep in mind, and these remaining 4 things are the ones which you can make on your own by doing very little bit of side change and simplification, that is taking square root of both sides. Isn't it? Am I clear? I hope you have got it correctly, right? So third one is the one I'm moving to. Third one is cosec square theta minus cot square theta is equal to 1. Yes, the one for which I kept you waiting is cosec square theta minus cot square theta equal to 1. So how to prove this? Just approach in the very similar way. I hope you can do it on your own. Still फिर भी मैं दिखा रहा हूँ, ठीक है? ओके, देख लो. Cosec square theta minus cot square theta. What was cosec theta? Cosec theta was a reciprocal of sin theta. हाँ जी, देख लीजिए और एक बार. Cosec theta was a reciprocal of sin theta. What was sin theta? Sin theta was perpendicular by hypotenuse p by h. So cosec theta is equal to h by p, right? H by p whole square. So but cot theta was a reciprocal of tan theta. What was tan theta? P by b. So cot theta equal to b by p. B by p whole square, right? So h square by p square minus b square by p square. P square coming as LCM in denominator, or in numerator is coming h square minus b square. What was h square minus b square equal to as per Pythagoras theorem? That is equal to p square. देख लो. A square minus b square is equal to p square. Am I right? अरे सर, इसमें राइट होने का क्या मतलब? ये तो बहुत सिंपल सा चीज है, मुझे तो सही से पता, पहले से ही पता, फिर भी मैं पूछ रहा हूँ आपको. Yes, in order to revive your knowledge what you have learned earlier, okay, or you knew a few minutes ago from my video. All right, so be clear to your understanding. H square minus b square is equal to p square, right? P square upon p square is equal to 1. So LH is equal to RHS हम साबित कर चुके हैं. So all the 3 identities are done. Again I'll show you some little bit of derivations from this basic form of identity by doing very little bit of side change and very little bit of simplification, like taking square root of both sides. So what this thing is going to fetch you? Cosec square theta equal to 1 plus cot square theta. Yes, you can easily understand by taking minus cot square theta to the right hand side. From here you can again write cosec theta equal to root over 1 plus cot square theta, right? और उसके बाद फिर देखो, हम अगर माइनस कॉट स्क्वायर थीटा को राइट हैंड साइड पे ले जाए, ओके, तो क्या रहता है? कोसेक स्क्वायर थीटा माइनस 1 इक्वल टू कॉट स्क्वायर थीटा. ओके, माइनस कॉट स्क्वायर थीटा को राइट हैंड साइड में ले गए हैं हम, और प्लस 1 को एल एच एस में ले गए हैं हम, ठीक है? cosec square theta minus 1 is equal to cot square theta. से बाद taking square root of both sides you can get cot theta equal to root over cosec square theta minus 1. All right, these 5 are also literally the same thing of the very first one. Okay, the one I've kept within box, cosec square theta minus cot square theta equal to 1. Okay, in class 11 you're going to get a relationship between angles and sides of any kind of triangle. A by sin A equal to B by sin B equal to C by sin C. Okay, keep it in mind. The relationship is like this: A by sin A equal to B by sin B equal to C by sin C. This, okay, the ones in numerator are small a, small b, small c. The ones in denominator are capital A, capital B, capital C. You can easily understand capital A, capital B and capital C are angles, because along with sine, cos and tan, these ratios, all what comes is angles, only acute angles. Moreover, keep it in mind. Okay, so small a, small b and small c, the sides opposite to the angles capital A, capital B and capital C. And okay, and each of these three relations are going to be equal to 2r. But what is capital R? Capital R will then be the radius of the circumcircle of the triangle. Keep it in mind. The angle is going to be like this. This is capital A, this is capital B, this is capital C, the angles. This side is small a, this side is small b, this side is small c. For any kind of such triangles, this relation holds true. This thing, and along with this relation, many other relations are also going to come in the chapter named properties of triangles. Okay, so which will be there in course of syllabus of mathematics of class 11. So in higher mathematics, all these things are going to come sequentially, one after another. But this is the very beginning, the basics of trigonometry. This is quite important and significant branch of mathematics. Keep it in mind. Okay, so that's why I thought of making a small video in order to help you all. Okay, for whom these things are not yet clear, they're not getting to understand, right? Well, so that's what this video is all about, the very basics and fundamentals of trigonometry, only for the beginners, for whom these concepts, these things, these theories are not yet clear and understandable. All right, I hope you have been able to understand these things. Okay, as I have tried to make you understand with the best of my ability. All right, so if you find the videos helpful, please like, share with your friends, and please keep commenting the topic on which you want me to make videos for you. This is my new channel, which I have opened in order to help you in basics of physics and mathematics up to class 12. All right, so thank you, all the very best.